what we've got here is a picture that sort of looks symmetric. I mean, if we draw a line here like this, then what happens on the left of it sort of looks like what happens on the right, except not, because we've got what we call a long tail on the right here. So what happens on the right sort of tails off. This is typical of when we're going to be looking at clinical trials data later. Anything having to do with survival, there's very often a very long right tail. If you've had experience in the lab, you know that you're waiting for those rats to die in your lab experiment. You just have to come back at 2, 3 in the morning because there's always that one rat who refuses to die. That's the right tail down there. You see, we love symmetry. We love symmetry in statistics. And because it just makes things a little bit more easy to explain and more powerful. And one thing we can do to achieve, to get closer to symmetry, is instead of looking at the raw diastolic blood pressure, what we could do is take the logarithm of those numbers. So for each person, if we took the logarithm, we can define a new variable, which is related to the old one by just taking the logarithm. And what we get, if we do the histogram of the logarithm of diastolic blood pressure, here it is, we see something that's very much closer to symmetry. So this tail is sort of pulled in. We sort of pulled this tail in quite a bit. So this is a common device that's used in statistics, that we don't just look at the raw data sometimes, we transform the data. So here's one transform, namely the logarithm.